Hi everyone, this is the Plan to Change team and we would like to present our food waste analytics and reduction engine. This is brought to you by our team of Arya Upadhyay, Isabelle Wong, Kevin Richard, and Srihan Sandha.
Food waste is a global problem that can be exemplified in not only most major cities, but Atlanta as well. Every year, a significant portion of food produced ends up in landfills, creating a massive environmental impact. In the United States alone, 80 million tons of food are wasted annually, about 38% of the food supply. This food waste is worth over $444 billion and is equivalent to 149 billion meals. A whopping 40% of food that farmers around the world produce is never consumed.
Where's the waste coming from? 40% comes from restaurants and 2% comes from manufacturers. A whopping 43% comes from household waste. Now the question is, how can we effectively control the food waste from households?
While milk and dairy contribute 26%, grain products 19%, meat 12%, and seafood 2%, fruits and vegetables account to 42% of the average food waste thrown away annually. Consumerism has fed the narrative that food waste is normal, and this culture of waste has long plagued the world with injustice to the people facing hunger and malnutrition. Fruits and vegetables that are essential to a healthy diet are most often quickly perishable, hence thrown away. But how gravely does this affect the average consumer?
In a survey conducted by Food Navigator, the number one reason people throw out food is because no one in their household was interested in consuming the leftovers, closely followed by the food has lost its flavor or become stale. This in turn shows the key components of the problem of waste.
FWARE is a digital platform designed to analyze patterns in food consumption and waste, providing personalized recommendations to reduce waste. By inputting data on food purchases, consumption, and waste, users can receive insights into their habits and tips on minimizing waste. This involves scanning receipts, manual entries, and even photographing their meals and waste. We made an algorithm that analyzes input data to identify patterns of waste. For instance, frequently wasted items, quantities, and potential reasons for waste, like overpurchasing and spoilage. Based on the analysis, the platform generates personalized recommendations for reducing waste. This includes shopping tips, meal planning advice, proper food storage techniques, and recipes designed to use up leftovers or near expiry items. This would also allow local restaurants, grocery stores, and even households to post available surplus food. Users can list items, including details like type, quantity, and pickup location. We also implemented features that engage users in community-wide challenges to reduce waste, such as the Zero Waste Week. We also implemented features that have reward systems that gamifies the waste reduction process, offering badges, points, or even local discounts for achievements that are incorporated. The app also includes a section for educational materials on the environmental impact of food waste, composting guidelines, and sustainable eating practices. This promotes broader awareness and education on the issue. In all, FWARE empowers individuals to become mindful consumers while also fostering a collaborative community to tackle a significant global issue.
There are many useful features this app can have. You can scan or manually enter receipts or even photograph your meals and waste. The app can give you shopping tips, meal planning advice, proper food storage techniques, and recipes designed to use up leftovers or items nearing expiration. In doing all these things, an in-app reward system will usually turn this into a game where you can get badges, points, or even local discounts while participating in the waste reduction process.
MLOps is the process of making a machine learning model and deploying it as a production system. Similar to DevOps, good MLOps practices increase automation and improve the quality of production models, while also focusing on governance and regulatory requirements. The two approaches at the cost of each are shown. Prices are estimated using AWS infrastructure and third-party engineering for deployment support. We see two reasons for adopting an MLOps framework as we gear up for today's ML models. One, If one does not fully plan for the entire support system required for a successful machine learning program, then any individual project will at best have short-lived success. A deployment project will either fail to be adopted by the business due to a lack of confidence, or it will become a critical part of the business process and then fail at a critical juncture. And 2, cost. MLOps streamlines operations and reduces the long-term burden on engineering to produce a new model from scratch each time.
Through this solution, almost over 130 meals will be delivered in Atlanta, with 345 families impacted either through food waste management or food delivery/jobs. We anticipate this number through a survey we took from the local area wherein we received 400 participants from different regions.